Okay, good morning class. So today we're looking at analytical geometry. We're looking at the examples for exercise 11.4. Okay. Okay, if you want the explanation of this, you'll find it in the description box below. Alright, so something to note here, gradients of lines. We said that x1, so the delta, your gradient is delta y over delta x, it refers to the slope. If you got y, the gradient is yp minus yq over xp minus xq. But if you go yq minus yp, it must be over xq minus xp. Again, if you want the full lesson of this explanation, you can find it in the description box below. Also here, we got a mistake here, it's delta y over delta x. Okay, so if lines are parallel, we made the note, if lines are parallel, gradients are equal. Then we came across this conjecture, which is the mathematical observation. If lines are perpendicular, then the product of the two gradients is negative 1. There's something else we must add there. If points are collinear, like that, because it's off, I didn't see it here. If points are collinear. So what does collinear mean? It lies on the same line. Yeah, it lies on the same line. Okay. So if you draw a straight line, and you got 3 points on that line, then those points are collinear. Okay, so let's just draw a line here. If you got A, B, and C, so basically a straight line, right? So if points are collinear, then gradients are equal. So gradient AB will be equal to the gradient AC, which is equal to the gradient of BC. Okay. Those 3 gradients calculation will be the same. Why would the gradients be the same? Because it's on the same line. Anywhere along that line will have the same gradient. Not so. So if points are collinear, then what's the name will be the same. The gradients will be the same. And then this important note here, that this line L1 is parallel to x-axis, so the gradient is 0. It's parallel to the y-axis, has an undefined gradient. Again, those lines will also be perpendicular. Not so? Yes. Alright, now we're looking at the example, and this example is on page 255. Example page 255. Example 1 on page 255. We are told that ABC is a quadrilateral with diagonals AB and BD. AC and BD. Thank you. The question says, prove that AB is parallel to DC. We must prove that AB is parallel to DC. People, if lines are parallel, what do we know? What is equal? The gradients are equal. If lines are parallel, gradients are equal. Okay. So what do we have to do? We have to work out the gradient of CD. So let's go with C, 7 and 11, and D, which is 2 and 6. How do I work out my gradient? It's YD minus YC over XD minus XC. If you had written YC minus YD, it will be over XC minus XD. You guys understand? So let's go. YD. YD is going to be 6 minus 11 over 2 minus 7. So now gives us negative 5 over negative 5, which is 1. The gradient is going to be 1. So if we can prove that AB's gradient is also 1, we've done the job. Not so? So let's go with the gradient of AB, which is YB minus YA over XB minus XA. If you had gone YA minus YB over XA minus, get the same answer. Okay. And we did that last year when we drew graphs. You remember? I showed you. Both ways the same. So the coordinates of B is, what is that? 8 and 4. And A is 3 and negative 1. People, that's X and a Y. XB, YB, XA, YA. Not so. So XB is 4 minus 1 over 8 minus 3. What's 4 plus 1? 5, and 5 over 8 minus 3 is 5, which is? 1. Hang on, what do you see? Yeah, equal is. So I'm going to pull this to the side so for a while. A little while. So we say, since. It reminds us of geometry. No? If they ask you to prove that or show that, we always end off like this. So what do you think you're going to write? Since you're stating the obvious, the gradient of CD is equal to the gradient of AB, which is equal to 1. Therefore, CD is parallel to AB. Okay. So these lines are parallel. Okay. Now let's look at the B part of the question. Okay. B. We want you to prove that AC is perpendicular to DB. People, if lines are perpendicular, what do we know? The product of the two gradients is negative 1. Okay. So we must work out the gradient of AC. So how do you work out that? It's going to be YC minus YA over XC minus XA. So the coordinates of A is 3 and negative 1. C is 7 and 11. So let's go. YC is 11 minus 1 over 7 minus 3. So what does that mean? 12 over 4, which is 3. So the gradient of AC, the gradient of this line is 3. So if the gradient of BD, what was the gradient of BD be if it is perpendicular? Negative a third. No? Why? Because it's additive, it's additive inverse. Okay? Because if you multiply 3 with negative 1 over 3, what do you get? Negative 1. You said 3, negative 3. It's going to give you negative 9. Not O, it's a 9. Huh? You look like a O. But anyway, so let's go with the gradient of BD. So that would be YD minus YB over XD minus XB. What's the coordinates of B? 8 and 4. And D, 2 and 6. So let's go. 6 minus 4 over 2 minus 8. That's going to give you 2 over negative 6, which is negative a third. So hang on. Read business, not so. Pull this up. So how do you think we're going to end this off? Okay, let me just pull this up quickly. Too fast to wait. Okay, I'll just pull it down again. Yes, he's saying since the gradient of AC times the gradient of BD. People, this is lowercase m. Why am I doing this? M, small m, and subscript BD. No? Not capital M. Okay, since the gradient of AC and BD is equal to 3 times negative a third, which is equal to negative 1. Therefore, AC is perpendicular to, people, this conclusion is 1 mark. If you do that properly, get the 4th mark, okay, or the 5th mark, depending. People, you guys understand? Any confusion? No, okay. Okay, we'll do another one. People, this is the example on page 256. Here we are told, determine the coordinates of D. If in each case the points A, B, C, D are given by A is negative 1 and 3, B is 2 and 4, and C 6 and 0, and D is X and 4. If AB is parallel to CD, AB is parallel to CD. So if AB is parallel to CD, then that is your diagram that we're looking at. Can you see that, people? If lines are parallel, what do we know? Gradients are equal. Not so? Right. So if you're going to go with AB parallel to CD, you must work out the gradient of AB. Remember in the previous question they asked you to prove that the lines are parallel. So how do we prove the lines are parallel? To prove that the gradients are equal. Here we are told the lines are parallel. So what does that mean already? The gradients are already equal. You guys understand? Again, if it's a proof that, we must show the gradients are equal. If they tell you that it is parallel, the gradients are then equal. Okay? So, through calculate the coordinates of D, or X in D, if AB is parallel to DC. So, the gradient of AB is YB minus YA over XB minus XA. Alright, so YB is going to be 4 minus 3 over 2 minus minus 1, which is 1 over 3. Not so. So the gradient of AB is 1 over 3. Then we go to the gradient of DC. So how do you work out the gradient of DC? YD minus YC over XD minus XC. So YD is 4, this is now minus 0 over XD, which is X minus 6. That is simply 4 over X minus 6. Can I cancel this here? No. Why? Because there is a minus between. So what do we do from here? We say, if lines are parallel, gradients are equal. Okay, so we go here. You don't have to write this. If lines are parallel, gradients are equal. So that means you say that the gradient of AB is equal to the gradient of BC. Okay. So what about right now? Therefore, the gradient of AB was a third is equal to gradient of DC is 4 over X minus 6. So what do I do now? Cross multiply, yes, well done. 1 times X minus 6 x minus 6 is equal to 4 times 3? 12. So x is equal to 18. You guys understand? Again, if they ask you to prove lines are parallel, what we do? No, so not prove. If they ask us to work out your value for x, for which lines are parallel, we work out the gradient of AB, the gradient of CD, and then we see them equal to each other. Okay? Let's look at B. Am I moving too fast? No, okay? Let's look at the B part of the question. In B, they are talking about the lines of perpendicular. So which means to say, we need the gradient of AB and the gradient CD. Can you see that, people? Lines are perpendicular. So what we need to work out? The gradient of AB. But you say, hang on, didn't we work out the gradient of AB already? So are we going to work it out again? No, there's nothing wrong with us yet. Okay? So we keep that. Right? So if this is your B part of the question, we just start from there. We know that the gradient of AB is a third. You don't do a calculation again. Then what do we need to do now? We have to work out the gradient of DC. But you say, hang on, we worked that out already. Double D. No, that's D1 and D2. However, it's the same D. It's the same D for now. No? So, the gradient of DC was what? When we worked it out? 4 minus 6, no? 4 over x minus 6. Okay. So again, we don't have to do the calculation twice. Okay. So what do we know? If lines are perpendicular, then gradient 1 times gradient 2 is equal to negative 1. So with that in mind, what can we say? We're going to say that the gradient of AB times the gradient of DC is equal to negative 1. So what's the gradient of AB? A third times 4 over x minus 6 is equal to negative 1. Okay. So we must multiply this in here. It's 4 over, or divided by a third. It's 3x minus 18 is equal to negative 1 over 1. Cross multiply. So 4 is equal to negative 3x plus 18. Negative 3x is equal to negative 14. Therefore, x is equal to 14 over. Do you guys understand? Right. Last one. This example is on page 250. 7. Also 6. Also 256. Okay. So here we are told that show that A, B, and C are collinear. What does collinear mean? Lies on the straight line or on the same line. People, before it's lies on the same line, what do we know? Gradients are equal. So we know that AB's gradient must be equal to BC's gradient, which is equal to AC's gradient. However, if you can prove that 2 of the 3 gradients are equal, we don't have to work out the third. And if the 2 of the 3 is not equal, automatically the third one won't be. So we only test for 2 gradients. Okay, so let's go. The gradient of AB is going to be YB minus YA over XB minus XA. YB is 2 minus 3 over 0 minus minus 2, which is negative half. Okay. So we can do the gradient of BC or the gradient of AC. Okay. So it's going to be 1.5 minus 2 over 1 minus 0. Now 1.5 minus 2 is negative half. 1 minus 0 is 1, which is negative half. So hang on, what do we notice now? They're equal. So what do we say? Since the gradient of AB is equal to the gradient of BC, which is equal to negative half, therefore A, B, and C are collinear. Okay, will you guys understand? With that you should be able to do exercise 11.4. Okay, you do for me out of 11.4. You do number 1, first column. Number 3. Or you can do actually the whole thing. Okay. Joe is already there. Good afternoon. That basically brings us to the end of the chapter on analytical geometry. If you want further calculations, you can find it in the description box below.